Now, talking of DeFi on Solana, that's been one particular domain that's been around ever since crypto evolved, right? So transactions in DeFi are the more complex, right? And which requires you to be smart in how you define a particular set of operation in your business. So perp trading, almost everyone in the audience, I suppose, would know about it. And that's what we are going to talk about. How do you structure your programs, and how do you build your client, and how do you make sure all of those transactions land and your users can trade perps. So let's get started. So let's start with the problems that we face as DeFi builders. And the first is runtime costs. If you're running a business, then you have operational costs, and DeFi on Solana is no different. So the first cost that you incur, you as a builder, as well as people who are going to use your platform, are going to pay fees, transaction fees. And that is comprised of the base transaction fee, which is 5K lampots per signature. And the other component is the prioritization fee. So both of these fees add up when anyone does anything with your platform, right? Now let's look at the scale. This is something that everyone knows, right? Talking of scale, let's say you've got to do an Oracle update, which is the most common operation in DeFi, and then you've got to do it at least once per second. Talking of from a very broader perspective, going to milliseconds and microseconds would be great, but just for a simple case, let's talk about one transaction per second that updates your oracles, all right? Now here you see the calculation, 5K lampots, 86,400 seconds in a day. That gets us to a cost of 432 million lampots a day. Let's make it simple. It's 0.432 SOL per day. That's your operational cost. At the current price, I'm sure it's gonna be around $100 a day. That's your cost for updating one single oracle if you do it in the bad way, right? $100 a day for each market that you're going to support. FlashRate supports more than 15 markets across a lot of domains, including gold, silver, oil. So yeah, there's a lot of stuff that we do. So at this cost, it's going to be bad, right? The second problem, runtime latencies, right? Everything that you do or your user does will have some latency because of these two things. They're either going to land a transaction, or they're going to get the feedback of what happened after the transaction landed, which brings us to these two versions of latencies that we see, which is read and write. Now, a lot of other speakers before me have spoken about those two ideas, including Xoheb from Astrolane, one of our transaction landing partners, allowing us to speed up stuff. And the other was also, including a lot of other speakers, I think it was Harsh, talking of XDP and the improvements to the whole read layer. So all of these things coming together, hopeful that we'll have a lot of improvements on the latency layer. Not much that app developers can do here, but work out a stack that reduces ultimate latency and catch up the scale where other people are in terms of running exchanges, right? And the third thing with the problems while building in DeFi is the runtime limits, which is going to be an important factor in the talk here. So like, I would love if you guys have attention to this. And they come up with the first thing, which is max block units, right? Which defines how many compute units can be spent in building a block. That constant is set to 100 million right now. But then we have SIMD 0370, which is just going to get rid of everything. Thanks to Fire Dancer team, we will not have this cap. So as a builder, maybe you're not worried about this as much. But then the next thing, which is the writable account units, which is the amount of compute units you can spend in updating the data or writing to a single account. I wish I had a better definition to this, but nothing defines this better than this. Anyone seen this tweet? Yeah, that's talking about pump.fun and a program design that they made, which updates a single account every time a transaction happens on the pump swap program, right? Which leads us to this problem where if one single account is going to eat up more than 12 million compute units in a block, transactions using that account will be dropped. So you cannot have your transactions included if you're exceeding this limit. So this is a decision which you need to take before your program goes to mainnet or before you deploy to prod, right? Maybe pump team overlooked, or maybe they know better, but as a builder, you should be careful to not let this ruin your progress as you scale, right? When you're testing, it doesn't matter, but when you have thousands of users using your platform, you're going to run into these issues fairly quick. And we come to the third important runtime limitations, which is max transaction account locks. This could be defined as the number of accounts your program can lock when operating in a single transaction. So what can be done atomically is defined by this limit, right? Any guesses on what the value is? Maybe it's 256 because that's what transaction context defines max account per transaction to be 256. But no, that's not a limit for you as a builder in building the transaction. That's more for the validators to worry about. Then we have a second reference which says 128. You've got the link right on the screen. You can navigate, and there you see that max transaction account locks is set to 128. Now you would assume, okay, that's the limit. That is the number of accounts I can use in a single transaction. But then there's a catch, because it may be 64, because as you see on the screen, the bank file literally defines it as a conditional statement. And for those of you who have been with us since the 22 era, 3 years back, we've had this interesting rollback for increased transaction account lock limit. This is a feature gate. You can check the status on your CLI, and you'll know that this feature is deactivated or deprecated for mainnet. And the catch here is that this limit is 128, as you saw before, for DevNet and testnet. In your testing environments, this is the limit that you get. But on mainnet, when you deploy, surprise, you're limited to 64. And your transactions, if they use more than 64, they're silently dropped. You've got to look into why your transactions don't land, and you figure out that, okay, this constant exists. Nightmares, but yeah, finally, lesson learned. So these are the lessons, or these are the problems that you should be careful about as a builder before you kind of have your apps deployed to prod. So make sure you're aware of all of this, and then we can talk of solutions. Number one solution is to have a well-defined program architecture, right? Use PDAs, but use them smartly. Unlike what we saw just before, right? You have one account that literally locks up everything, and maybe you forget about the limit of number of accounts that you can use in a single transaction. Be wary, be smart, and make sure you know what you're doing. And then, second important solution is to make sure your design doesn't exceed the runtime limits, which you spoke about all along. And then you can use instruction introspection to do complicated tasks which require more than 64 accounts, for instance. Like, what would you do in that case? We don't have a solution for that, but if your transaction also does a lot of stuff involving flash loans or doing something across different protocols, if you've used anything that involves multiply or anything that involves borrowing money from elsewhere, doing a certain transaction and returning that capital back, which is involved in a lot of loops and multiply products in DeFi, you would see them using instruction introspection, which is literally taking an X-ray of the transaction, seeing what you're doing step after step, right? And this way you can like build a lot more complicated flow in your design, where you can do a lot more than just doing CPIs and getting limited by by the limit. So here you have a good example of how to use introspection. So feel free to scan the QR code and then get started with how introspection works, right? We'll move on to the third solution here, running short on time, so gotta keep it quick. Reduce costs by cutting compute wherever possible. This brings back to our idea of, we calculated the fees to be like 100 SOL a day if you're just paying for transaction signature cost, which is the base fee of 5K LAMP ports. If your transactions are going to use a lot more compute, you've got to also pay a priority fee. So that can add up really quick. In order to overcome this limitation, you can use precompiles. Precompiles are special programs on Solana which do the computation or do all of the operations before runtime is invoked, right? This was introduced back in the day where you did not have signature verification protocols deployed to the runtime. So you can use instruction introspection combined with precompiles to have conditional flows. The way we use it is price messages, right? Instead of having to update the oracles all the time, you can use this as a default to have a backup price message or maybe an updated price message verified via precompiles at your disposal. The best thing about this approach is that it takes zero compute. And that is the reason we have Trent complaining about it. And then unless we finally see them being deprecated, precompiles can be a great way to extend your transactions without having to spend a lot of compute. And users would just love it because they're anyways not going to pay the additional compute fee associated to it. So that's the solutions that we have today. And that's the whole crux of how to build your protocols, especially if you're looking to scale in DeFi on Solana and have a chance to compete against all of the other DeFi protocols out there which are not on Solana.